go. So lesson 10.6 says solving right triangles, and the goal obviously is to solve a right triangle. So our first word, our first vocab is to solve a right triangle. So what does that mean? Solving a right triangle means to find measurements. So find measures for all three sides. And all three angles. Now you'll obviously always have one angle because it's a right triangle. So you'll be finding the two acute angles and the three sides. Inverse tangent. We use inverse tangent. It looks like tan with a -1. That means inverse tangent. And so if you look on your calculators, guys, above tangent, you should see like a tan to the -1. So we're going to do second tangent to get to tan -1. So that's going to be second, and then the tan key. And what we do is we use this to find an angle from its opposite and adjacent sides. So from its opposite and adjacent sides.
You wrote and twice.
To find an angle, thank you. To find an angle from its opposite and adjacent sides.
Now we criticize the teacher. I'm sorry. I apologize.
If you guys notice, on your videos, your vocab is typed out, so I can focus on typing and not talking and writing at the same time. What do we think the definition then for inverse sine would be? Yeah, it's going to be sine with a -1. So that means we're going to go to second sine. And then we're going to use this to, this is going to be to find angles. When we know opposite and hypotenuse. So I'm trying to abbreviate there, ladies and gentlemen. So we're going to look at these diagrams, and if I have the side opposite of an unknown angle, and I have its hypotenuse, I can then use inverse sine with that ratio. We are still using SOHCAHTOA because we're looking at when I have opposite and hypotenuse, that goes back to the S. But if I have to find the angle measurement, then I have to use inverse sine for that. Okay. Some of the problems you will still use SOHCAHTOA to find one of the sides of the triangle. The book takes you through doing sine using SOHCAHTOA one time and then doing the Pythagorean theorem. You could use SOHCAHTOA 2 times, so it's up to you what you want to do. I just want to see what you're setting up each time. So if you're going to use SOHCAHTOA twice, I want to see both equations like you did on the worksheets and the quiz. If you're going to use SOHCAHTOA once and then Pythagorean theorem, I just need to see your c squared equals a squared plus b squared. Ian.
What is that in
That's an and sign. Is that a little bit better?
Yeah.
That's my sloppy ampersand. So ladies and gentlemen, I would kind of expect you guys to be able to move ahead and fill out cosine yourselves. So who thinks is going to be the first thing we write for inverse of cosine? Zena?
We're going to put cosine like we did at the top.
COS with the -1. That -1's like a little exponent. What am I going to put in green in parentheses?
Second cosine.
Second cosine. So then we're going to find angles when we know what? What do we need to know to use cosine inverse?
Adjacent and hypotenuse.
Adjacent and hypotenuse. Good job. So I'm going to write that down. with you guys as you do that. So it's to find angles. So it's to find angles. When we know adjacent and hypotenuse. All right. So are we ready to take a look at how to use our calculator to do that, guys? Oh, good. I'm waiting. I'm holding on. 10 more minutes. Sergio, I'm going to start making some spitwads up here. Just start throwing them at you.
Can I back fire?
Just make like a huge big one. You just have to like chew on it for a while and then you turn into a big.
All right. Can I go on now?
No!
Yes, you can go ahead.
Gilson's almost, it's like the exact same thing. You just had adjacent and hypotenuse. And Ian, what is this between adjacent and hypotenuse? The and sign. All right. So ladies and gentlemen, here's what inverse tangent is going to look like. To find the inverse tangent of angle A. All right. So if the tangent of A is equal to Z, then Z it's going to be Z over 1. So to find A, you're going to type tan inverse. I don't like how they have this typed in here, guys. So tan inverse of Z over 1. You're going to take opposite over adjacent. That's a Z. They've got a Z here. Well, I guess I'm looking at your books. Is it a Z they have in your book? Okay. I have to put that through my Z's or else my 2's look like Z's and my Z's look like 2. Alright then, for inverse sine and cosine, if we look at angle A, guys, if I need to find this angle measurement, because notice there's no degrees there in angle A. There's no degrees in angle B. So I can't find A by subtracting from 90 because I don't have angle B. So what I can do is if I have the sine of angle, if I want to find A, I can take sine inverse, and that's going to be opposite over hypotenuse, so y over 1. I don't understand quite why they have this written here, guys. So to find sine inverse, it would be, to find angle A, it'd be sine inverse of y over 1. If we wanted to use cosine, we would use the adjacent side. So we would type in cosine inverse of x over 1, adjacent over hypotenuse. Why is it called the inverse? Inverse operations undo each other. So we call addition, subtraction, inverse operations. And so tangent takes the angle and gives you the fraction, the decimals. If I do the inverse of it, it'll take a fraction and turn it into an angle measurement. So we use inverse just to describe two things that undo each other. Sure.
So when you put it in the calculator and you can exponent,
No, it's actually, let's get to the point where we're using some of these in our calculator. You don't have to put the exponent in at all. Cosine inverse, this actual button is on your calculator. You're going to hit second cosine, and that should bring up cosine to the -1 on your calculator. All right, so here, guys, let's use the inverse tangent. All right, so it tells me you want to find the measure of angle A. So if I'm looking to find angle measures, that's where we said, Sam, we're going to use our tangent, sine, and cosine inverses. So I want to find the measure of angle A. You're going to start these, ladies and gentlemen, the same way we started yesterday's problems. I said label opposite, adjacent, and hypotenuse. This is opposite. This is hypotenuse. This is opposite because it's across from the angle A. That means 10 is your adjacent. So because 8 and 10 are opposite and adjacent, that's how I know how to use tangent. Your book is quite nice to you today, guys, because it'll tell you use inverse tangent. Okay, and then they'll give you a set of problems to do that. I'll use inverse tangent. The tangent of A is equal to opposite over adjacent, okay? Which is 8 over 10, or you can call it 4/5. Okay, if you want to simplify it, you don't have to simplify your fractions. Okay, guys? That means the tangent inverse of 4/5 will equal the measure of angle A. All right? So let's go to the calculator. Let's see what that looks like. So if we go to our calculator, we're going to type in second tangent, guys. So, Jordan, you were asking about the exponent. You see how it automatically comes in? And then I'm going to type 8 divided by 10. 38 point, and whatever place they tell you to round to. So 38.7.
Yeah.
If you had done tangent inverse of 4/5, it'd give you the same exact answer. Or if you did tangent inverse of the decimal, if you call it 0.8, it's going to give you the exact same angle. So it doesn't matter whether we use the original fraction, whether we use a fraction in simplified form, or whether we use a decimal. All three of those take us back to the exact same angle of 38.7 degrees. So what does it say to write it as? Nearest tenth? Is that what it says in there? Alright, so use the tangent inverse formula. The tangent inverse is that 38.65, blah, blah, blah. 38.6598. So rounded to the nearest tenth is 38.7. So 38.7 degrees. All right. Those of you who need calculators, I'll get more after notes. All right. Yes. Oh, sorry. So now we're up to the part where it says solve a right triangle. Is that the next example in your book, guys?
Wait.
Oh, it says follow up, doesn't it?
Yeah.
Where it says look something up in your book, cross it out. We're not doing that. That's how I used to have to do it when I was in school before they had scientific calculators for everyone or graphing calculators. So I'm not going to embarrass you by showing you guys how old people do it. Alright, so I need to find each measure to the nearest tenth. It says to find C, and then it says to find angle B. So to find side C, it tells you it's the Pythagorean theorem. And for this problem, that's what you need to do, because right now you have 0 angles. So you can't use sine, cosine, or tangent. Alright, guys? So when you use the Pythagorean theorem when there's no angle measures. And Hunter, I think you asked about that. Could we use sine, cosine, or tangent to find a side? In this case, because there's no angle measurements in there, remember how we have to type in like tangent of 42 or sine of 35? Because there's no angle measures, we're going to have to use Pythagorean theorem here. So we're going to take the hypotenuse. What's the hypotenuse in this triangle? C. So it's going to be C squared. And our first leg, I'm going to do the smallest one is 2, 3. We have C squared is equal to 4 plus 9. So we have C squared is equal to, what's 4 plus 9? 13. And then they tell you to take the positive square root. So the square root of 13 should be 3 point something, am I correct? 3.605. It says to round to the nearest tenth. So we'll say 3.6, am I correct? All right. It was 605.
Oh.
It's 3.605.
Yeah.
All right. Now I need to find angle B. So let's label our sides. This is the, what's 2 going to be labeled as? Opposite, because it's across from angle B. Why did I put a mark in angle B again? And it's because it's an angle and because they're telling you to find it, right? That's why I need to pick angle B. C, we said, was the hypotenuse. And so 3 is going to be what? Adjacent. So what 2 sides do you have measurements for? Opposite and adjacent. If we think of SOHCAHTOA,
So.
Which ratio has opposite and adjacent in it? Tangent. Alright, so that's how I know to use tangent. So tangent of B is equal to 2 over 3. So that means I'm going to take tangent inverse of 2/3. So you're going to go to your, oops, I should put a 1 there. So you're going to go to your calculator. And you're going to type in second tan, make sure you got the tangent inverse. And it was 2 divided by 3. Yep. And so we should have it about 33.7 degrees.
Yeah, how did you know?
Oh.
Look what I got up here.
Go.
I'm not that amazing. So the tangent inverse is this 33.69000. So we're going to call it 33.7. Please label them with degrees, ladies and gentlemen. Yes. Do you have it in degrees? Is this in your calculator? I got that to read. So try it again. See if it gives you what we need. Yes. Hurt? All right, ladies and gentlemen, checkpoint. Use your calculator to find angle A to the nearest tenth. You know the tangent of A is 3.5. So what operation do we do to get back to an angle?
Inverse.
Tan inverse. So I'm going to type tan inverse, and what am I going to put in the parentheses?
3.5.
The 3.5. Get her done. And what did we get for number 1? I need to get my answer key out. Guys, I'm back recording, so I don't want to hear you. Yes, so that if someone's absent, I don't know if we have any, like Callie's absent today, she'll still be able to watch this video. It's just going to be a much longer video because we're stopping and pausing and talking. So, Ann got 74.1. Do we agree? Degrees? Did you all get degrees? All right, Sam, number 2.
Wait, 63.642.
I got 60, my book says 63.4.
Yeah.
63.4.
I just added the 3 on.
Ah, okay. And then 23.8 degrees. Did I hear that from someone else? All right. So they gave you what tangent was equal to, right, guys? All right, 4, 5, and 6. You need to write the tangent ratio and then take the inverse of it. Go, for Kelly. The adjacent side.
Ooh.
The adjacent side is 9. So I'm going to take the tangent of A is equal to 5 over 9. But then to find what A is, I know I have to do tangent inverse of 5/9. So for the when they give you the diagram, you actually have to start those problems from the beginning like we were doing last week. You have to write that ratio. The nice thing is that ratio will always have 2 values equal for the second one.
40.4.
Tangent of A equals 17 over 20. And what does tangent of A equal for the third one? 16 over 10. So now, well, but and she's like, wait, that's all we had to do? No, you had to do tangent inverse. But can you get tangent inverse unless you're setting up the right fraction? No. So now those of you who had the right fractions can volunteer with your answers. So, who wants to volunteer for number 4? Who thinks they have the right answer? Heather.
29.4.
29.1 degrees. If you didn't do it or got it wrong, write in 29.1. Who thinks they have 5?
I have 5.
Grace. 40.4 degrees. Nate, do you think you have number 6?
0.
Good job. That's exactly what it said. Beautiful. Woo. All right. You had 57.9.
Yeah.
I'm probably not going to be too picky. Right now, guys, what I'm trying to get you to is the point where you can write these ratios correctly. And if you're getting 57.9, then I know you're writing the correct ratio. All right, so find the measures of an acute angle. So A is an acute angle. Use your calculator to approximate that. So it's the same thing, whether they give you sine, cosine, or whether they give you sine, cosine, or tangent, we're going to use the same method. So if the sine of A if they give you sine of A is equal to 0.55, then to find the measure of angle A, sine inverse has to equal 0.55. So we're going to do sine inverse on our calculator of 0.55. When we do that, so sine inverse is no different than tangent inverse, except I'm hitting second sine. So second sine of 0.55. And I get 33.36701. Round to the nearest tenth of a degree is 33.4 degrees. So I'm going to be able to find angle measures, whether they give me opposite and adjacent, whether they give me opposite and hypotenuse, or for the last one, because it says cosine, they can give me adjacent and hypotenuse. Eric?
So every problem, do that right? 33.267.
No. They just give us this blank, so I'm showing you guys what the blank was meant for. I would expect you guys to go from your calculator screen to 33.4. Please and thank you. All right, so cosine inverse of 0.48. So cosine inverse of 0.48, you guys are typing in. So second cosine, 0.48. And that is 61.314597. That's simply just to fill in the blank. So what are we going to look for in an actual answer? 61.3 degrees. Yep, I will leave it there.
This is so long. This is so long.
I know. You're doing it in class. Just quit whining.
I'm not lying.
Oh, you're not.
I was just,
Seeing an observation?
yeah, I was just pointing out that.
Are you guys all done?
Yeah, I can go.
All right. No. Eyes back up front. We are only on 9 of 11. 3 more. Stick with me. All right. So solve for a right triangle. This was also part of the reason I knew this was a long lesson. A lot of examples. And I wanted to be able to. My husband's like, will it really make a difference with them in class? I'm like, yeah, because I can just call their name out. So, what'd you get? And then get their
You
attention
should
back.
do that in one video. It's like, okay, here.
What are you Here, what are you doing?
This is
All right.
all get practice.
Solve triangle GHJ.
It'll be like Dora, like, good job, even though I didn't say anything.
Dominoes, 30 on, let's go. I know. That was very not
Is that
cultural.
racist?
Not good on my part.
Is that racist?
Not meant to be, but that could have been interpreted that way, correct?
Yes. That's
Thank
why I
you.
took it.
Sergio, you're going to throw me under the bus, aren't you?
Yes, I'm gonna call Jones.
All right, ladies and gentlemen, here it is. This is our culminating activity. This is our last example before the checkpoints. This is where we finally solve a right triangle. This is what we've been waiting all lesson to do. There are 3 parts. Find the measure of angle G. Find the measure of angle H. And then find side G. I would start by finding your angles first. You have 2 sides, so it's enough information to find the angles. I'm going to start by finding angle G. All right. What are we going to label 16 and 25? Well, 25 is hypotenuse, correct?
Yeah.
And Eric said cosine, which means 16 is the adjacent angle. All right. So I'm going to pick cosine. Part of it's because it's here, but I picked cosine because I have 16 over 25. So that means you're going to be able to do cosine inverse. They give us a lot of extra blanks, guys. I'm not sure why. Well, they want you doing a lot of simplifying of your fractions. I don't think it's necessary. So you're going to go to your calculator and do cosine inverse of 16 over 25. All right, that's exactly what I would want to see you write down. Cosine of G is equal to 16 over 25. Cosine inverse of 16 over 25 and then round that directly to the nearest tenth. So this will be 50.2 degrees. Now notice, ladies and gentlemen, they don't have you doing sine, cosine, or tangent of angle H. They have you now doing what we did in the warm-up. Do 90 minus the angle, so 90 minus 50.2. And 90 minus 50.2 should be 38.
39.
Thank you. 39.
Luckily my 8 wasn't.
39.8.
39.8. Got my 8 ahead of myself. 39.8 degrees. So even though you have two missing angles, you only have to use the sine, cosine, or tangent inverses one time. We then use the definition of complements. Now what you're going to do from there is you have two sides. You could use one of your trig ratios, like Hunter had asked, can we still use SOHCAHTOA? Yes. You could find this opposite side by using opposite and hypotenuse, okay? I like using Pythagorean theorem. It's something we've been using, but if you want to set up a trig ratio, you can. So we're going to take 16, or g squared, plus 16 squared is equal to the hypotenuse squared. So that's going to be g squared plus 16 squared is equal to 25 squared. G squared can't be simplified, but 16 squared can be. 16 squared's got to be like 296, 256. Thank you. So 256 and then 625. You're going to subtract the 256 from each side. So the solving isn't any different whether we're just finding sides or finding sides and angles. So g squared is equal to, let's see, 625 minus 256 is equal to 369. Take the positive square root, so you're going to take the square root, so g squared, and you're going to take the square root of 369. Once again, round it to the nearest tenth. They're using that direction for everything. So the square root of 369 is 19.2. All right? Oops.
So if we use SOHCAHTOA, we have to use X and X.
Yes, if you use SOHCAHTOA, so like if I went through and said, okay, this is opposite of over hypotenuse. So if I use sine of 50.2 is equal to, guys, Grace asked an answer. She said if I use SOHCAHTOA, it's going to work out the same way. This is the opposite side that we're trying to find when we find G. So if I do sine of 52 equals G over 25, how am I going to solve for G? Times by 25 on each side. So if you go to your calculator and you do 25 times sine of 50.2. So if I do 25 and then sine of 50.2, we're going to get that same answer of 19.2. Now, depending on how much rounding we have to do, whether we round up or keep it the same, this could be off by one place value, but we should always be getting within 1/10 of each other. Okay? But so you can use the sine, cosine, or tangent. You can use the Pythagorean theorem. Ladies and gentlemen, I would like you guys to do number 11 on your own. I'm not going to test your calculator skills. I know you guys rocket them already. Oh, you got them done. Finish them. All right, 7, 8, 9, and then 11.
Wait, what?
7, 8, 9. Go back and do the calculator problems because I got yelled at when I took them off.
No, you don't need to do that. Isn't that supposed to be the other way around? You're supposed to yell at us.
I don't know. I get yelled at by all my students, so.
Wait, are we doing the second side?
Yes. And then you're doing number 11. I want you guys to find angle G, or angle E, angle D. Ooh, angle up. 7, 8, 9. Calculator problems.
That's too long.
Oh my lord. Yeah, the calculator ones should be done. If you move your fingers as fast as you move your mouth, you'd be done. No, I'm not. I'm done talking to him because I'm going to get coffee. I am done talking to Sergio. That was weird. It was not meant to be that way. It was Garrett and Sergio.
That was pretty funny though.
I'm gonna do an interview with Anderson Cooper.
No.
He made everything a lot worse. We're like, look at that example. Yeah, he's got AIDS. Why are we gonna come to him?
Oh, I feel like it was interesting.
And then he brought in the Jews. He's like, when a Jew becomes successful, he helps his people.
Was it Anderson Cooper who was interviewing him?
Yeah, and when I thought he was talking, I'm like, stop. They're not fixing anything.
Yes, he did not do his reputation any good.
Just admit what you did, and then, be honest. He might not.
All right, did everyone start by finding angle E? All right, what is 4 going to be labeled as? Adjacent. What is 6 going to be labeled as? Hypotenuse. Now, ladies and gentlemen, if you chose to find D first, would you be using adjacent or hypotenuse? No, you'd be using opposite and hypotenuse. So is our work going to look very different depending on where we start the problem at? So I'm not going to be able to necessarily have a worked out answer key for you that's useful. But what you can do is show your work, and when your answer doesn't match, then I can look at your work. So I should see this cosine of E is equal to 4 over 6. So I should then see you guys writing down cosine inverse of 4 over 6.
What if you reduce this like
2/3, that would be fine. Ladies and gentlemen, do you see what I'm modeling here is what I want to see when you're doing the homework today and tomorrow, okay? So cosine inverse of 4/6, or 2/3 as Eric said, is going to give us, for angle E, 48.2 degrees. What's our quick shortcut for finding angle D? Subtract it from 90. Once you have your one angle, so we're going to do 90 minus 48.2 degrees. Yep. And then Jesse, how am I going to find letter Y? How do we do that? How do I find this letter Y? How do I find this missing third side?
I'd say it's about 5.
4, 5, 6 would be very nice. It is going to be a decimal though.
5.5.
Question, Eric, or going to tell me what to do?
4.5 maybe.
Do the A squared plus B squared equals C squared? Is that what you're saying? Yeah. So I'm going to do 6 squared is equal to A squared plus 4 squared. You can put Y in here, guys, so that you know you're solving for Y. So 36 is equal to Y squared plus 16. Subtract the 16, so you get 20 is equal to Y squared. Take the square root, and Y is equal to about 4.5. Yes. That's why I didn't have you guys do 10 or 12, so you can write over into those boxes. Eric.
That's not what
Yeah, because I want you guys to be able to know whether or not your answer makes sense. And I know for my leg, it has to be less than 6, because 6 has to be the longest side. So if you were to take the square root and get an answer bigger than 6, you know you have something up here you need to do. Without actually taking that square root and getting a decimal, I don't know how many of you can estimate whether that answer is bigger than 6 or less than 6. So that's part of the reason that I've resorted back to those decimal values. Okay? Ladies and gentlemen, to check your answers here, sine of A, the inverse sine gave you 30 degrees. This was 23.1 degrees. And 6.6 degrees. All right? Occasionally, ladies and gentlemen, you do get exact answers, exactly 30 degrees. All right. We only have a couple of minutes left, ladies and gentlemen. So what I want you to have done when you come to class tomorrow, I would like you guys to have fourth. Oh no, I didn't give you any homework. I have all tomorrow for classwork. All right, never mind.
Thank you.
I gave you guys no homework 2 nights in a row.
That's what you love out.
Please do, because I don't have my grade sheets on the top. Thank you.
Woohoo!